ZW is giving away 2 brand new Seestar S30 Pros in their brand new processing competition. They provided 2 images to process, one of which is M31, and in this video I'll show you how to quickly process M31 using Siril. I also have a version in PixInsight, so if you're curious about that, check that video out. If you don't already have the file, it'll be on their Google Drive, which is linked to from their Facebook post, which I'll put in the description. This is going to be a pretty quick video. I don't go deep into anything, but the steps that I'll show you today will include cropping and rotating, plate solve in SPCC, and then using a couple of the VeraLux scripts, including VeraLux Nux to do a gradient correction. The new SyQon script for star removal, that actually prompted me to redo this video. I recorded this yesterday using StarNet, and today I had to redo it with SyQon just because I had to test that script out. And then we'll use VeraLux hypermetric stretch to do our stretch, but you can also use generalized hyperbolic stretch if that's what you like. And then we'll do some curves and saturation adjustments using VeraLux curves, noise reduction with Graxpert, and then finally we'll recombine our stars using VeraLux's Star Composer script. This is just one workflow. There are many others. You can also do workflows where you don't remove the stars at all, save a couple of steps, and just do a stretch using VeraLux hypermetric stretch or generalized hyperbolic stretch, or both. Before we get to the demo, I just want to say that if you'd like to support me and my work and have a say in the kind of content that I create, check me out on Patreon and on Buy Me a Coffee like these wonderful people and consider joining that list. Alrighty, so I have my home directory set. It doesn't really matter since we're editing just one image, so I'll just open that one image. It's going to be this thing here from ZWO. I will switch my viewer to auto stretch, unlink, let's move it here. I'm going to do a quick crop, mainly because if we look at the bottom right corner here, we have stacking artifacts. So this tells me that this was from field rotation and this was imaged most certainly in Alt-Az and not equatorial mode. So we'll fix that. So right click, crop, crop. I'll switch the orientation, so image processing, geometry, rotate 90 degrees, and then I'll click on this little button here to fit the image to window. And now we have a really nice view of M31 to work with. The first thing I want to do is I want to go to Tools, do Astrometry, and then Image Plate Solve. I want to solve this so that we can do SPCC on the stars so that we get some nice colors later on. The right ascension declination should automatically pre-fill because this particular image has all of the right headers. You can use Siril Solver or astrometry.net. I'm just going to stick to the simple Siril Solver. I use my local star catalog and click OK. Took less than a second. Next, we'll go to image processing, color calibration, spectrophotometric color calibration. You want to make sure the OSC sensor is Sony IMX585 because that's what the S30 Pro is using. Even though you'll see an S30 option here, don't click that, that's a different sensor. The OSC filter should be UV IR block, and then click on OK. I got the white balance summary plots here. These look okay to me. Click close, close, and close. And now when we stretch the stars later, we should get some really nice colors. But before I do that, I want to actually remove the gradient here, and we'll use one of the VeraLux scripts. So when you zoom out, you can see the gradient here. It's like really dark on this side and not so much on that side. So we'll go to Scripts, Python Scripts, VeraLux, and VeraLux Nux, which does a really nice job of getting rid of the gradient. So I'm really impressed with this script. And I find that with this particular image at least, setting to auto-calculate does a really nice job. I don't even have to mask the galaxy or anything. I'll click on Save Gradient Model so I can look at the gradient later. Click on Process. Looks really good. You can click on the eyeball to see exactly what was removed, and this confirms what I was able to see with my eyes. So really cool. Close this. Here we go. And it can go back and forth. And you can see that the background looks so much better, and the galaxy also pops a little bit better. Now the next part is what made me actually redo this whole tutorial, because Siril today introduced under Python scripts processing SyQon Starless, which is a brand new script. The first time you run this, it'll take a little while because it has a lot of dependencies that it needs to run. And most of the time, default settings work. I believe the default tile size is like 368, but I ran this a couple of times and I noticed that this thing gets rid of M32, which is a dwarf galaxy in around M31, because it thinks it's just a big bloated star. So I find that increasing the tile size to 896, or even going all the way up to like 1024, it'll slow down processing, but it's pretty fast, and that seems to help. and then increasing the overlap. But default is 32, but going to like 64. This thing works really fast anyway. I kept the pre-stretching tuning to be the default, and you want to make sure that generate star mask is selected because we want the stars back later. So click on process. Even with big tilt, it works pretty well. You can see that it did mostly still get rid of M32, but not too bad. So maybe that's something to work on for SyQon and their model. So I'll click on close this. And the next thing we want to work on is just stretching this. So I'm going to switch my viewer from auto stretch to linear. I'm going to go to scripts, Python scripts. I'm going to go to VeraLux and then do hypermetric stretch. Do a live preview. Just like the SPCC, you want to make sure the sensor profile is set correctly to IMX 585. You can do an auto calc here as well. Looks pretty good. Turn off adaptive anchor. You can play with the settings to make this look a little bit better for your screen. I think this looks fine. This is a good initial stretch. I'll click on process, close this, and this is our stretched image. So I'm going to click on save as. I'm going to set this as M31 VHS for VeraLux hypermetric stretch, so that just in case I can come back to it. We can make the galaxy pop a little bit more by doing a curves adjustment. So go to scripts, Python scripts. We'll use VeraLux curves. Right, once we're on the screen, I'm going to do a quick S curve to make the galaxy pop a little bit more. You can also use the curves adjustment that comes within Siril here. It works just as well, but this has some more finer controls, which I really enjoy. You can also use the luminance controls here to enable range, so like what you want to image. And the way you see what you're affecting is to click on show mask, and then you can play with this to see what you're affecting. Right, so I'm gonna try and make sure I only affect most of the galaxy. I'll leave the core alone. Do a little bit of feather. Okay. Turn off show mask. Click apply. Do a little bit of luminance and S curve as well. Click apply. And I like doing this in 2 steps. So I'm going to click process so that it processes the curve stretch here. And then I'm going to go back to the same script. And I'm going to go to the S for saturation and bump up the saturation so we can see the sweet, sweet blue around the arms of the galaxy. Click apply, and then I'll do the same thing for chrominance. Just a tiny bit. Okay. And then click apply and process. Now with all that done, I probably could have done a little bit better of a job with the core itself. It's kind of blown out. So that's my fault on the stretch part, but click save. I'm going to go back to Python scripts, VeraLux, and I'll do Revela to do some contrast adjustments on the dust lanes there. So I'll do both texture and structure. Just some slight adjustments makes this look really nice. You can go back and forth. You can see just how much the dust lanes in the galaxy start to pop. Great. The next thing is we have quite a bit of noise here, and I'm going to fix this using Graxpert because I find that I have to get the best results with this. Switch to denoising. I'll switch the strength to like 0.75. Click apply. All right, close. I can go back and forth. You can see it looks a lot better. Yeah, and the more I process this, the less happy I am with the core. So forgive me, viewers. So I'm going to click on save so that that data is saved. And the next thing we're going to do is bring our stars back. And I'm going to go to scripts, Python scripts, VeraLux, and then do star recomposer. I'm going to open my star mask and then my Starless. You can also use the built-in star recomposition tool in Siril. It works just as well. Make sure the sensor profile is good and use screen. And let's bring the stars back. So I'm going to be pretty aggressive with this. So I see that some of the stars look kind of wonky, and let's fix that. So I'm going to up the shadow convergence and also decrease the color grip. So that they blend a little bit better. And then I'll click on Star Surgery because I think I need that here. Okay, just played with this for a little bit, and I think this looks okay. The stars look good. The cores of this and this could probably look a little bit better, but I think it's okay. Just don't pixel peep. Okay, I think this is good. I'll click on Process. All right, there we go. That looks pretty nice. And I don't know if this translates well in the YouTube video, but on my screen here, I see a little bit of a green halo around the galaxy itself. So I'm going to go to Image Processing, remove green noise, keep it at default, and then click on Apply. Yeah, there you go. It actually makes the galaxy pop a little bit better. So that looks kind of nice, right? We get some of the blue. You can play with the curves a little bit more, make it pop a little bit more, but I think this as a final result is really, really nice. But this is the final result, and I'm pretty happy with it. Comparing it to what I got out of PixInsight, let me know which one you think looks better. The two versions are what I had, and these two versions are what I had out of VeraLux and GHS without doing a star removal. They look nice too, but the stars could definitely use some star reduction. I am very impressed with the new SyQon star removal script. Comparing it to StarNet, it works a lot faster and it does much better with smaller stars, especially when I tested this out on the Milky Way image that also came from the Seestar S30 Pro from ZWO's contest. I'm very much looking forward to testing this script out even more. If you use my workflow to process M31 or any other images, I would love to see it. Consider joining our Discord server where it's a growing community of astronomers and astrophotographers, and we'd love to have you. The invite link is in the description below, so join and share your images there. Until next time, happy stargazing and clear skies.